Hello. Just going to linger here a little bit, make sure that it's working, and open the chat. Let's see, I think we're waiting still. Waiting to go live. Well, I think YouTube says we're live. I don't see it on my phone yet, but I'm going to continue anyway, so I'm not in. And short presentation, it's very casual, it's not really a presentation, of my final project for new musical interface design. So I'm a composition major, and this is my only class I've ever taken in the audio arts and acoustics department. But I had a really good time, and I learned a lot of things. And this is the final product of that class. And the assignment was to design a musical interface of our own imagination, however we wanted to, whether it be physical or digital. And I went the digital route, so mine actually runs in the web browser here. And so I'm just gonna show you how it works, and then talk about it more, show you a little more, and then talk about it a little more. So it's just this blank, simple web page with a solid color, and use the keyboard and the mouse to enter in these little particles. And you can interact with them. It's a 2D physics simulation. So you can see they fade out over time, and then you can't click them anymore, but you can add new ones. And the key mappings for these, let's open the keyboard. It's the same as Ableton Live's keyboard piano. So A through L are the white keys. W, E, and T, Y, U, and O, because I have that top D flat up there, are the black keys. So it's just 1 octave plus 2 semitones range, but there are also transposition keys, so you can get quite a range. So if you press Z, you go down octaves, so that one's so low you can't hear it. But you can see that the brightness of the color changes by the octave, and the hue of the triangles also is determined by what pitch class it is in a scale. Well, it's not entirely true, because when you transpose it, it shifts everything, but you can kind of get to know the scales that way. So the number keys are also used for transposing semitones. So if I hit 0, then we're back in C. I'm way up there in the octaves because I pressed it a bunch of times. So we have a C major chord. And you can just kind of toss them around with the mouse and create fun, chaotic, musical and melodic patterns with it. Something that's also fun is you can actually alter the direction of gravity using the arrow keys. So if I press up, now the gravity goes up, and to both sides. I'm not keeping an eye on a chat, but thanks Armando for all the hype. He's my hype train. This is my first ever stream, so thank you. And then you can also toggle gravity on and off. There are 2 modes of gravity. I'm calling them constant and applied. So the default is constant, where in real life it's just a constant value down. That's probably something scientifically incorrect about that, but and then I just hit slash, and that turns it to applied gravity. So it's 0 gravity until you apply it temporarily with the arrow keys. So that's another way to kind of control your gravity. I actually find that applied gravity ends up being easier to control and easier to manage, but constant gravity is fun too. You can also add, I'm going to reload the page here. You can change to a different voice. So these are, each particle is a synthesizer, but if you press C, then you change to sampler mode. And right now the samples are hard-coded in there, but I plan to add the feature to allow users to load their own samples. So right now it's just some basic drum samples. And these particles are circular. So it's really great if you want that like vintage drum machine falling down the stairs kind of sound. There's also a settings menu that you can open up with Q, and gravity and voice toggle do the same things that I already described before, with slash being the toggle for gravity and C being the toggle for the voices. We can also choose the waveform for the synth particles. So we have 14 different ones. There are 4 basic ones. There are 2 pulse ones. Pulse width modulation, the pulse width is changing, and pulse is just a pulse signal with a steady width. And then there's also 4, there are frequency modulation variations and AM modulation variations for the main 4. So you can get a bunch of different timbres, and you can mix them. So I just entered in some FM sawtooth particles, but then if I wanted to add some sine wave particles to that, I could have them both in the same environment. So some of these settings only apply to the new particles that are added, including lifespan, which says how long in frames they're going to last for. So it depends on how fast it's running for you. It usually runs at 60 frames per second. It should. So the default, which is 600, should be 10, I think. I'm not a math major. And then we have some physics parameters too, like bounciness and friction. And these end up being some of the most useful ones, especially bounciness, because you can really start to like create a more chaotic system, especially in applied gravity mode. So if I turn the bounciness past 1, then we get some erratic behavior from these particles. And I can turn down the size. I'll talk more about that later. And then enter in a bunch of particles like this. And then what you can do is just kind of grab one and drag it around. So that's one of my favorite ways to play it, is by just kind of having these floating particles in applied gravity mode that are extremely bouncy, hyper-reactive, and then I just slowly drag one of them around and kind of stir things up. So we have particle size controls. The particle size is randomized, and I wanted to keep it that way because I think that helps create variation in the system. But I also want to be able to adjust the probability in a certain direction. So we have a minimum value here. I should zoom in on this because it's kind of hard to see probably. Particle size minimum and particle size maximum. So I made the maximum 500. I think that's actually too big, especially for certain window sizes, because you get like some really stupidly big particles. But I don't know, it's fun. I kind of want it to be controllable by the user as much as possible, but also keep it simple at the same time. And then we can also just change the background color, which is nice if you want to like screen record this and do some compositing on top of a video. And the color changes for the mode, so you know which kinds of particles you're entering before you enter them, but you can make them the same too. So I think that's all the features. Trying to remember if there's anything else, but I'm going to stop talking for a bit and then just kind of play around with it for a bit and show some different ideas for what you can do with it. This isn't getting processed by anything else other than what's coming out of Google Chrome. So I'll talk more about what JavaScript libraries I use to generate the sound. But just imagine that you can pass this audio into Ableton Live. You can pass it through effects. This is really fun with a looper or delay units, or just record it and then loop find within whatever you recorded. There's a bunch of different ways to do it, but I'm just going to be showing you what's coming raw out of the browser. So keep that in mind, that it's going to be less like a performance and more like just throwing these particles around. Yeah, so I'm going to stop talking and just play around for a bit. Okay, so that was just kind of whatever. But let's see, we got a question, some memes. This is fascinating. Do the shapes make the same sound no matter where and what they collide with? And it seems the dynamics are controlled by how quickly the objects were moving before they collided. Yes, that's something I forgot to point out. And what you're hearing, I think, is the filter cutoff of each particle has a filter, and the cutoff frequency of that filter. So basically, how dark or bright the sound sounds is determined by the velocity of that particle. So you can hear it very clearly with like a sawtooth wave, for example, where you throw it around. Well, okay, maybe not. Let's start one really slow. So you can hear like the filter's kind of opening and closing, and it's kind of resonant, so it kind of has that like acid-based sound. That's something I want to make more controllable by the user too, is like the cutoff frequency and the resonance of that filter and what kind of filter is applied and all that stuff. There was something else. Okay. So during that improv, you might have noticed after I had been playing with it for like a minute or two, I tried adding a percussion particle and like the whole thing blew up. Good thing I put a limiter on this. But that's a glitch that I'm not sure why it happens, but I noticed that I kind of have to reload the page when I use the sampler mode in order for it to not... I don't know. I feel like maybe as the amount of particles gets added to the system, it increases the gain of this. I don't really know. I have to investigate that, but be warned, I should probably put a warning label on this. Okay, so I'm going to talk a little bit more about like how I made this now that you've seen it. So I'm very new to programming. I kind of just started learning a few months ago, and this was like my first big project. So I learned from the coding train, who has lots of really helpful and very charismatic YouTube videos and live streams about programming in Java and JavaScript and using an environment called processing, which is what I started out learning to make MIDI reactive animations from Ableton Live. Whoops. That was very fitting. But I started this sketch after watching this coding challenge, which is a series of videos he does about just wanting to make something and then trying to make it in a matter of like usually an hour or something. So he used this 2D JavaScript physics engine called matter.js to do it. And the part that interested me about this coding challenge is he tried adding a sound effect that happened when the balls hit something. And this is exactly what I wanted to do. So I took this code as a base with Matter.js and P5, which is the JavaScript version of processing. And then I attached a JavaScript library called tone.js. Hence the name tone toss, is because you toss the particles around and it's powered by tone. And it has all these really cool musical features. And I really only use a couple of them. I'm just scratching the surface with tone. So I used tone.synth, which has an oscillator with all those waveforms that you could select in the menu. It has a built-in envelope that I just trigger when a collision event is detected. And then I just mix it with some basic mixing where there's a tone channel, there's tone reverb. That's the thing I forgot, reverb. There's a built-in reverb, and you can control its wet and decay right here. That's the one setting I forgot to talk about. So if you want to kind of look into the code a little bit, I have it all on GitHub. By the way, you access this thing at eelromance.github.io/tone-toss. And on that GitHub page, you can find the code. And I kind of went through and did my best to comment it. But because I'm a beginner programmer, I wouldn't really recommend looking at this as like a prime example of programming, because it's far from that. It's very hacky. I could do this way more efficiently if I knew what I was doing. But if you wanted to try to make a variation of this or something like it, or you had an idea where, oh, if I could use this as a base, then I could add this, then you're free to go ahead and do that. And that's how I made it. So I encourage that kind of attitude. So I could try to go through this code, but I feel like it would just very quickly turn into a mess. But basically all you need to know is there are two JavaScript classes that I'm using, particle and particle drum. This is just the melody and drum particles. And each particle has their own tone synth in it. And it has each object gets passed in the frequency of that that oscillator needs based on whatever key was pressed. And then it triggers the envelope of each particle's oscillator when matter detects an event. So that happens here. It's pretty convoluted. So I think that's probably about as far as I'm going to go. But I would recommend, if you're interested in this stuff and interested in developing creative stuff for the web, to look into P5 and to look into tone.js, especially for musical applications. The possibilities for it are really quite staggering. And you can check out some of their fun demos on this site. Ableton used it to do like learning music demos on their website. And there's a bunch of cool projects. Is there any other questions? Thank you. Nice work for first coding project. Thank you. Is there any sort of panning going on with the current version? Oh, using a spatializer. That would be really interesting. I'm not heard of the Ambisonics spatializer, but I don't know if that's something that you do with Macs or if there's a kind of JavaScript version of that. Maybe there is a feature in Tone that would produce something similar. Doesn't look like there's a spatializer. There is 3D panning though. Here we go, a spatialized panner node. So yeah, I just need to read through this documentation and figure out how to apply it. But I think that would be easy-ish. But I think that's a really good suggestion too, is making this flat 2D canvas more 3D in your ears using spatial panning. That's a neat idea. After this, I want to continue learning to program for interactive musical apps and such. I love the democratic nature of making it for the web, because you can just send someone a link and they can just try it as long as they have Google Chrome and a keyboard and a mouse. But I also am interested in developing for virtual reality devices. I just got my first Oculus Quest and it's blowing my mind. And there's a very vibrant community of developers on there. So if I can wrap my head around that this summer, then I'm going to totally try to bring something like this to the 3D environment of VR. But definitely continuing to do web stuff and add more features to this, like MIDI input and output would be huge, because then you could send this to a hardware synth or to a DAW to play with it even more. I just think it's a fun kind of aleatoric way to just create rhythmic and melodic patterns, and it's very intuitive and not very musical looking, but it's kind of like a toy, and I feel like that's an approach to creating music that is very refreshing to me. When I see a musical instrument that looks more like a toy, it inspires play and imagination, and it kind of creates this illusion. Well, it's one of my favorite aspects of music is activity in music, and interesting sorts of activity in the arrangement and the overlapping and layering of different active elements. And so I like new tools that feel like they have that embodiment in the instrument. So yeah, that's all I'm going to talk about this. You can check out my website, cameronl.ee. I just got up and running, so it's probably buggy, but I'm going to continue to post blog posts and stuff like this on there. So thank you guys for watching this stream. And particles breaking upon collision. Yeah, so that could trigger a whole another set of events. People could add their own boundaries to the system. There's so many directions I could go with this, and the learning curve just gets steeper and steeper, but it's still exciting to me, so I'm going to continue going until I just can't anymore. So is there any process programming sketches you could show that got you to this point? I'd love to see the next iteration having multiple users simultaneously. This is very cool. Why are you so good looking? Okay, Armando, chill. So yeah, I could get multiple users going with WebSockets. WebSockets is something I hardly understand, but I know you can have like two-way interactions in browsers, and I know that the coding train has done multiplayer processing canvases, so I think it's possible. I'm not sure, but yes, I want to look into that. And what are the programs called again? P5JS is the environment. It has a web editor, so you don't even need to like get an IDE or whatever to get it running. You can just edit it directly in the browser, and you can save all your sketches in it too. It's really nice. Process programming sketches that I could show to get to this point. I'm gonna post more of them on my website. I have a few of them up on there already, or maybe just one. But also, if you watch the more polished, organized presentation version of what I'm talking about on this YouTube page, I show some of those there. And also my Instagram, which is Cameron Lee with all these E's. So, yeah, right there. Anyway, I think that's all for now. So thanks Vizda and the Audio Arts and Acoustics Department for giving me the opportunity to speak at Manifest. And I hope you all have a great summer of learning and creativity and fun, and go outside because it's a really nice day today. So thanks so much. I'm signing off. Did I stop it?